Hey there, let's check out this example together about the electric motor. This electric motor has a round coil of 0.2 meters in diameter and 300 loops, and it passes a current of 2 amps. The coil resides in 0.15 Tesla magnetic field. We need to find three things. First of all, we need to find the magnetic dipole moment, B, the maximum torque, and lastly, we need to find if the normal to the coil makes an angle of 30 degrees with the magnetic field, we need to find the torque. So there are three things we need to find. Okay, so if we look at this coil, it's kind of like this, of 300 loops, all right? And it has a radius r, or is equal to 0.2 diameter divided by 2, so that would be 0.1 meter. Okay, let's see. And it resides within the vicinity of a magnetic field. We don't know where the direction of the magnetic field so far, but let's see what we need to find. Magnetic dipole moment, and mu is equal to NIA. N is 300, the current is 2 amps, and A is pi r squared. So let's just plug in some of the information. So we have 300 for the number of loops. The current is 2 amps, and A is equal to pi times r squared, and we agreed that r is half the diameter and we need to square it. Okay. So this is pi r squared, which is the area of this whole thing, the coil, and that is, after some calculation, we can get it equal to 0.0314 meters squared, and that's multiplied by 2 and multiplied by 300. Then mu is equal to 18.84, and now let's look for the unit of the magnetic dipole moment. N is number of loops, that's an indication, it's not a unit basically. I is amps, and A is Newton, A is meters square. So it's going to be amps dot meters square, and that's the unit for the magnetic dipole moment. Now let's find part B, maximum torque. Torque max is actually when you calculate it without using the sign. So that will be mu times B with that, so sine theta, but that should be 1, or sine phi, that should be 1. Okay, then you can say that this would be equal to 18.84 times the magnetic field of 0.15 Tesla. So the maximum torque is 2.83 torque. Torque is measured in Newton dot meter. Okay, because torque is given by the distance times, or the arm of the force times the force. The force is in Newton, and the arm of the force is measured in meter. All right. Okay, so now the last part says if the normal to the coil here, which makes an angle 90 degrees with the surface of the coil, makes 30 degrees with the magnetic field. So they're telling us that phi is basically equal to 30 degrees. Let's find the torque. Okay, the torque is equal to mu times B times sine 30. That's it. Okay, sine 30, I remember it, it's 0.5. So mu is equal to, as we found it before, 18.84, and times B, which is 0.15, and this whole thing times 0.5. So basically you can take this number and divide it by 2, and the answer is 1.413 Newton dot meter. And that's it for this example. Thank you.